Hi, everybody, and welcome to another episode of Ok Xoomer. I'm your host, Aaron Licthig, a Xometry guy and former Jeopardy champion. And today, we're excited to be here with Dror Danai. He is the Chief Business Officer of XJET, and he has more than 20 years of experience in strategy and operations focused on the 2D and the 3D printing industry. Before he joined XJET, he worked on Skodek's digital enhancement printing. And throughout his career, he was also a leader at XJET Geometries, which was a company that later merged with Stratasys. And he is also the inventor of the term PolyJet, which is a 3D printing process that Xometry still offers. You can find it on our website. This is the man who made that up. And Dror, he also served in the Israeli military. He's had a wide-ranging career. So Dror, thank you for joining us today.
Thank you for having me today. Pleasure to be here.
Excellent. So first, let's talk about your company, XJET. Can you tell us a little about the history of the company and what you all do?
Well, the history of XJET is pretty long, but I will focus on our recent few years where we focused XJET on additive manufacturing. And what we developed is a unique technology. I think it's the only material jetting technology that deals with ceramic or metal AM. And the difference from any other technology, which are all fantastic, is that we don't start with any metal sandbox or of any kind. Instead, we start with a very, very simple tray that has nothing on top. And what we do is we bring, by inkjet, we bring droplets that include the material itself in its real form. Now, since we do all this jetting is happening in a very high temperature, the carrier liquid evaporates instantaneously and you are left with a layer. This means that this is very different from all other technologies. It allows thinner layers. It allows the use of real particles. It allows getting to much higher resolutions, smooth surfaces, and other geometrical and physical benefits.
Excellent. And I saw a recent article about some work that XJET did with a company called Marvel MedTech, which has a breast cancer treatment solution. Can you tell us about your work with them and how what you do enabled them to create a pretty revolutionary way of fighting early stage breast cancer?
Well, I met the founder of Marvel MedTech, I think it was a couple of years ago, at AMAG or at Rapid in the spring of 2018. And he came with his big life challenge that he's working on for many, many years, which is to create a probe that will go during the MRI test, that will go in the MRI, will be completely neutral to the magnetic field, and will allow the jetting of a special liquid to the exact location of the tumor in the breast that is found during the MRI. So instead of the MRI being just a diagnosis tool, it will be a tool like some other technologies where you treat the patient while at the same time that you find the problem. In this case, we are talking about breast cancer, from which more than 40,000 American women die every year. On a global scale, I think it's near to 500,000 people. So it's huge numbers. And in MRI, the statistics are very, very good. There's no false positive. So when you find a tumor, you know that it's real. And when you jet this special liquid that he developed, you really ablate the tumor, and the immune system gets rid on 100% probability gets rid of the tumor altogether and basically put an end to the problem. The missing link was the ability to create a probe that is indifferent or neutral to the magnetic field, the very high magnetic field in the MRI. In addition to that, it it's a very, very thin probe, and the channel through which the liquid goes has to be very accurate, it has to be very smooth, and it has to have no residual support structure. And when Mr. Ray Harter heard this presentation, he came at the end, and we started to look if we can really create this part. It took a while, and today we are very happy that Carmel system is in Madison, Wisconsin, and that it has great progress towards the final commercialization of this probe as a device that will change the nature of this disease in the US and later on, I think, on a global scale.
That's some really powerful work. And the key to that is that it's made from ceramic and that it's able to go into the body without disrupting the MRI field. Is that right?
It's a combination, exactly. It's very true. It's a combination of the unique characteristics of the ceramic on one hand, but that's not enough because ceramic was known for centuries, and definitely that was not enough. What you also needed is an additive manufacturing process that can create extremely small features and use support structure that is easily removed. So that was the missing link. So it's not only ceramic. Ceramic is very, very fragile. It's very hard to work with the ceramic, especially after it's sintered. Here in our process, we have no problem to get to extremely thin inner channels and to remove the support completely. So the combination of these technology abilities and the basic characteristics of the zirconia together created a probe that is now moving forward and allow this unique solution.
Excellent. Now, Dror, you've been in the 3D printing industry for a long time. And as we mentioned, you even invented the term PolyJet, which is still a popular 3D printing process today. So looking out over the next 1 to 3, kind of 3 to 5 years, what are some of the biggest trends you think will start to come to life in additive manufacturing?
I think the most important thing, if I have to pinpoint just one, would not relate to XJET or to any specific company, but to the notion of design for additive manufacturing. Design for additive manufacturing gets more and more central location in the industry, but it's not there yet. Many people try to do the same with additive manufacturing. And obviously, if you have any product, any part that you want to make in millions, there would be cheaper ways to make it. But only, and I read some very interesting blogs coming, I think, from Carbon recently about a new saddle for bikes. Once you use the unique design, once you reduce the weight, but not only the reduction of the weight. Take for example, our user in Delaware, the University of Delaware, that came up with a solution, a lens that can make a very inexpensive, very high quality passive beam steering antenna. This is a kind of a part that was impossible to do in other ways. It's impossible to mold something of this nature. It's impossible to machine using CNC or any other great technology. It is just something that can change the world of communication just because it's made of unique geometry, a geometry that is possible only with additive manufacturing. Same is true to the probe that we discussed earlier for removal of breast cancer. And I can have many, many other examples, even in consumer goods, where applying additive manufacturing just as a manufacturing technology is nice, but additive manufacturing is a lot more than that. Additive manufacturing is not about saving a penny. It's about allowing geometries that will save many dollars. If you think about anything that goes on a plane, for example. But it's even more than that. It's allowing certain parts and certain objects to be made and help the medical world or communication world or any other world in a leap progress rather than incremental progress. And I think this is, if I look into the future and if I look at the lessons that we got from the COVID crisis in the past few months, is that additive manufacturing allows people to do the impossible. And this starts to go into people's mind and maybe even people's hearts. And that will be a big change. That's my view.
And that's a great way to wrap up the interview, that additive does allow people to do the impossible. And it's fascinating technology. Dror, thank you for being with us today. Best of luck to you and to everyone at XJET. We'll be back with another episode of Ok Xoomer later this week. Take care, everybody.
Thank you very much. Bye-bye.